In this section, we're going to look at different types of regression equations, in particular linear regression, and tomorrow we'll take a look at how you do regression if it's not linear. So before we do that, we have a quick review. What is the definition of a function? So think about the Sneetches video that we watched first semester, and remember for every Sneetch that went in, one came out, and that's the definition of a function. For every input, there is only one output. For every x, there's only one answer, only one y. And so we're going to look at different types of functions. Again, we've seen all of these either this semester or last semester. We've seen quadratic, square root, exponential, and linear. So let's see if you can match them up with the appropriate graph. So we have four situations here. The average height of male children over time, the height of an object over time, the growth of a rabbit population, and the total cost looking at the number of games rented. So the very first one you should be able to recognize is the linear one, straight line, linear. And we've spent a lot of time looking at quadratics. So this one right here is a quadratic. U-shaped graph of parabola. And we have the other two that we spent some time on. The rabbit population starts out slow and then it grows, we say exponentially. So this is exponential. And the last one is the square root function, which we looked more at first semester. So today we're going to focus in particular at linear situations. We're going to look at data. We're going to graph it and find a line of best fit for linear, a linear model. So here's our situation today. We have the mean or the average height versus age for an 18-month-old to a 29-month-old in the average height in centimeters. So we're going to, instead of graphing this by hand, we're going to use the Nspire to graph it. We're going to find a line of best fit by hand and also by using the graphing calculator. And we're going to use that line of best fit to predict a future value. So let's practice doing this in the Nspire. So you're going to open a new list and spreadsheet page. So go home, open a new list and spreadsheet. And you're going to name this one right here, age. The first column, age. And then you're going to go down over and name column B, height. So the height over time. So your independent variable should come first, and your dependent variable should come second. Don't put anything in the equal sign. That's like if we had some kind of operation we would want our spreadsheet to make, which we don't. And we're going to type in the ages and then the heights. So you can go ahead and type those in. I think I did that beforehand, so I'm just going to close this and open the one that I made beforehand. Oh, which is right here. All right, so I've typed in all the ages and all the heights. And then it says highlight a cell that is not part of your data, and then we're going to make the scatter plot. So let's do that next. So highlight a cell that's not part of our data. Hit Control Doc. And we're going to add a data and statistics page to make our spreadsheet. Let's click to add the variables. We know age is the independent variable, and the height depends on your age, so that's dependent. And we can see that our graph, our data here, looks pretty linear. And we've done this by hand where you draw a line of best fit and find the slope and y-intercept. So let's do a quick recap of that. Here's our graph. Let's draw a line of best fit. A line of best fit should have the same amount of points above and below your graph. It should go through your data, have the same slope as your data, and it does not need to go through 0. So we can say, all right, this would be a good line of best fit right here. Again, notice it doesn't go through 0. All right, and this looks pretty linear. Write down the equation of the line. Let's do this by hand, and then I'll show you how to do it with your calculator. So by hand, we have y equals our starting value, 76 point, and here's 77, so how about 76.4, looks like. So there's the starting value of our line, plus our slope is positive. To find the slope, you pick 2 points and use slope formula. So I'm going to find 2 points that are easy to calculate. Let's just go over to like 78. So we'll go over here and go down. How about 80? We'll go down. Oops, that's not very straight. Let's try it one more time. Okay. So here are just 2 points I've kind of estimated here. And let's write what the coordinates are. So this is about I don't know, 20.4, 78. And the second point is you go over 24 and 80. So if you remember slope formula, it is, if we label this x1, y1, x2, y2. So slope here is y2 minus y1, or 80 minus 78, over x2, which is 24 minus x1, 20.4. All right, so let's calculate that. Your calculator, you can use a scratch pad. So let's do 80 minus 78. So that's 2. Okay, so that's 2 over 24 minus 20.4. And that's about 3.6. So our slope is 2 divided by 3.6. So let's go ahead and figure that out. So there's our slope is about 0.56 if I round. So 0.56x. Okay, so we have our starting value in height plus 0.56. This is how many centimeters you grow per year. Y equals 76.4 plus 0.56x. All right, let's use our calculator now to find that same line of best fit and see how close that we were. So we can go back to our current document. Let's go to menu. We're going to analyze the graph. We're going to look for a regression line. It looks linear. There's two ones. You can do mx plus b or a plus bx. I use a plus bx because that's the starting value first and then the slope. And here it is 64.9 plus 0.63x. That's pretty close to what we had. We had 76, but this is 64. So y equals 64.9 plus 0.63x. Oops. Let's see if I wrote that right. Okay. So let's use this one. It's more accurate. Again, you can see how close that we were, but this one's more, fits our data a little bit better. Okay, so now it says hit Control T to use the table feature, but that doesn't work with the regression line. Well, it does, but it's not just Control T. So I'll show you how to do that in a second. But let's figure out the average height for a 36-month-old, a three-year-old, 36-month-old, using the equation. So again, our equation was y equals 64.9 plus 0.63x. So today in your assignment, once you figure out the line of best fit, I'm going to ask you to make a calculation like this. I'll give you an x value, and I'll expect that you know how to plug in. So let's do that. This will be y equals 64.9 plus 0.63 times 36, and that will give us the value. So again, I'll go to Scratchpad. We'll do 64.9 plus 0.63 times 36. Little check. Okay. All right, so a 36-month-old will be on average about 87.58 centimeters. So on today's assignment, I'm going to give you a set of data. I'm going to ask you to use your calculator to find a line of best fit, to write down that line of best fit and use it to make a calculation. Now, if you want to see how to use the table to do this, I will show you that right now. All right, so again, let's go to current document. Let's say we wanted the table for this. Go back to this page right here. Oops. Let's put this up here. Okay. I'm going to stay in the cell that's not in our data, another cell that's highlighted. I'm going to go to menu. I'm going to go to statistics, stat calculations. Again, we want the linear regression. Our x value was age. Our y value was height. Okay. So we get our line of best fit is actually right here, but let's make the table for this. So go to menu, table, switch to table, and we're going to look at our regression equation table. So whatever one says regression equation. Here's our equation, and this says when time is 1, here's the height. When time is 2, here's the height. So we can go all the way down to when time is 36, and it should be that 80. Oh, I passed it. 36. It's that 87.78. So here's all the information in the table. You can see every month in the table versus just plugging into your equation. So you can use the table or you can plug into your equation today. All right, let's go over one more concept, something called a linear correlation coefficient, an R value. So if you take a look at these, if a graph has an R value of 1, what does that mean? So this has an R value of 1, 0.8, 0.3, 0, negative 0.3, negative 0.8, negative 1. So if a graph has an R value of 1, it means it's pretty linear, it's pretty well correlated. So it has a strong correlation. If a graph has an R value of negative 1, we say it has another strong correlation. So I should insert as a strong positive correlation. If the graph has an R value of negative 1, it has a strong negative correlation. If a graph has an R value of 0, it means it has no significant correlation. Okay, so again, if the R value is 1, it has a strong positive correlation. 0.8 is pretty close to 1. 0.3 doesn't have a very strong positive correlation. 0, no correlation. And then negative 1, a strong negative correlation. So we can use that to find the line of best fit. Again, I went over how you find the R value. All we did was, if I go to menu and go back to my list and spreadsheet, here is the R, here's the A value, the B value, here's the R value right here, 0.99. So in our data set, that line of best fit had a very strong positive correlation, 0.99, and R is 0.99, so pretty strong correlation. There's also something called an R squared value where they take that and square it, and let's talk about what that means. So R describes how strong or weak the correlation is. A correlation greater than 0.8 is generally described as strong, whereas a correlation less than 0.5 is weak. R squared is called the coefficient of determination, and it represents the percent of data that is closest to the line of best fit. So if you have an R squared value of 85, it means 85% of the variation can be explained by your equation, and the rest of the 15 doesn't really fit that line of best fit. So if you look at our R squared value, 98% of our data can be explained by our line of best fit, and only 2% would be off. So today we're looking at the R value, how strongly correlated is your equation. So your assignment, you're going to be typing in data, finding a line of best fit, using your line of best fit to calculate a certain value. And let's see if I have our assignment here. Here it is. Oops. Okay, so again, you use your calculator. I want you to make a scatter plot. I want you to find, this is not what I want, find the correlation coefficient R and the line of best fit, and then use your line to plug in and predict what will happen according to your line of best fit for like a 210 horsepower engine and so on. So again, 3 parts. Number 1, type in the scatter plot. Number 2, find the correlation coefficient. And number 3, use your equation to find a certain value. And you'll do that for tomorrow.